Breaking Python news, a simple algorithm that works similar to the way we sort playing cards using both hands. What is it? We are off to find out. We have our reporter Abdulwakil Bara. Kindly tell us about this, sir.
Yes, Franklin. Greetings to all Python's viewers. The algorithm that you have mentioned is called the insertion sort. As you have said, insertion sort is like the way you sort playing cards using both hands. We traverse one by one through all the cards and compare them with each other. The sorted cards will appear on the left of our hand, while the unsorted ones will appear on the right, until all of them are sorted. The array which is to be sorted divided into two sub-arrays, sorted and unsorted. After splitting, comparisons are done for each element in the unsorted array. This continues until each time in the array is sorted. This sorting algorithm is specially used when the number of elements in an array is less. It is also useful when the input array is almost sorted. Only a few elements are misplaced in the whole array. In terms of efficiency, insertion sort is not so fast because of the use of nested for loops. And that is all. This is Abdulwakil reporting.
Thank you, Abdulwakil. Now we will have our reporter Sairyl Lubguban on the line. What is the situation there, Sairyl?
Yes, hello Franklin. The situation here is that the students are confused about this hot topic on insertion sort. To make this clear, we will be backed up by Benjamin's back husbands. The idea of swapping adjacent elements to sort a list of items can also be used to implement the insertion sort. In the insertion sort algorithm, we assume that a certain portion of the list has already been sorted, while the other portion remains unsorted. With this assumption, we move through the unsorted portion of the list, picking one element at a time. With this element, we go through the sorted portion of the list and insert it in the right order so that the sorted portion of the list remains sorted. That is a lot of grammar, but you will get it in no time if you listen carefully, Pythons. This is Sairyl Lubguban reporting.
How to turn a great idea into a software product? Begin. Work more, work smarter, test it. Not working? Focus, try a new way. Your first win, but it's only a start. Follow the process, test again. You need to be sure. Go ahead, experiment. Oops, that hurt. But you don't stop. No rest today. Rely on your team. Stay the course. Improve the architecture. Improve the code. Improve the design. Go live. Get user feedback. Missing? Tweak it.
Okay.
Now you have a great product. Share your success. Celebrate. Call your mom. Make great things happen. Make a difference. This is how it's done. The way we've always done it. Time after time. Push the limits. Accept new challenges. And never, ever stop. For 25 years, bringing your brightest ideas to life. Alex.
Thank you, Sairyl. Now we have another reporter to enlighten us on the issue at hand. Sunshine Casido, kindly walk us through the explanation with an example.
Good day, Python viewers. Yes, Franklin, as shown here, we shall consider this array. The algorithm starts by using a for loop to run between the indices 1 and 4. We start from index 1 because we assume the subarray with the index 0 to already be in the sorted order. At the beginning of execution of each run of the for loop, the element at unsorted underscore list index is stored in the insert underscore value variable. Later, when we find the appropriate position in the sorted portion of the list, insert underscore value will be stored at that index or location. The search index is used to provide information to the while loop, exactly where to find the next element that needs to be inserted in the sorted portion of the list. The while loop traverses the list backwards, guided by two conditions. First, if search index is greater than 0, then it means that there are more elements in the sorted portion of the list. Second, for the while loop to run, unsorted list search index -1 must be greater than the insert value. The unsorted list search index -1 array will do either of the following things. Point to the element just before the unsorted list search index before the while loop is executed the first time, or point to one element before unsorted list search index -1 after the while loop has been run the first time. In our list example, the while loop will be executed because 5 is greater than 1. In the body of the while loop, the element of unsorted list search index -1 is stored at unsorted list search index. Search index minus equals to 1 moves the list traversal backwards till it bears the value 0. Our list now looks like this. After the while loop exits, the last known position of search index, which in this case is 0, now helps us to know where to insert value. And that is all, students. It's not that bad, right? Once again, I'm Sunshine Casido, reporting.
Thank you, Sunshine. How's the weather there, reporter Abdulajid?
The clouds are clearing up, Franklin. Lastly, to enlighten the weather that is the Python viewer's understanding of this insertion sort, I'm gonna show you how the algorithm works on each line of code. So, for index in range 1 len unsorted list, this line means that the sorting loop will start from the index 1 and will increment as the sorting continue. Assume that the element from the index 0 is already sorted. Search index is equals to index. On this line, the search index will be equal to index. So, insert value is equals to unsorted list index. Insert value will be the element of the unsorted list with the corresponding index. When search index is greater than 0 and unsorted list search index -1 is greater than insert value, the while loop will traverse the list backwards. If the first condition is true, it means that there are more in the sorted portion of the list, and if the second condition is true, the while loop will run. Unsorted list search index is equals to unsorted list search index 1. This statement will point to the element before the unsorted list search index as its new value. Next is search index minus equal to 1. After that, the search index will decrement and moves the list traversal backwards till it bears 0, and the while loop will continue as long as the conditions are true. Unsorted list search index is equals to insert value. This statement will be executed replacing the element from the unsorted list search index with the insert value. And the process will repeat with the next index until the list is completely sorted.
Excellent work, everyone. We hope that the students learned a lot. That is all for today. Here in Python News, your question or answer. See you tomorrow.